everyone, today we're gonna talk about generic text correction framework. I am Bo and my teammates are Shuomeng and Sili. So during last presentation in class, what we have covered is the problem definition and the algorithm side of the problem, which is the GHMM approach to query correction. So to complete the picture, today we're going to talk about our architecture and design of our framework. So here's the agenda today. Mainly, we're going to discuss 4 problems here. First, what is the problem we're trying to solve now? Second, what are the existing methods to solve it? Third, what do we propose? What are our ideas and architecture? And the fourth one, what we have achieved so far. And in the end, we're going to do a demo to demonstrate our current progress. So now I'm going to talk about problem motivation and definition. So the first one, text correction is a very, very hard problem. First of all, the problem space is diverse, and it is also very large. Therefore, it is very hard to return the corrected words very fast. And this is going to be even harder to correct a bag of words or like a sentence of words. Researches are conducted in this field, and there are complex algorithms. Models are very hard to implement. Therefore, a handy tool and framework can help researchers and professionals to run, test, and evaluate models efficiently. However, currently there are not so many such tools or frameworks that are available. Researchers and professionals oftentimes will need to worry about input, format, evaluation, and etc. So our main question is, can we build a generic framework for spell correction and related problems? Next, my teammate Sili is going to talk about existing packages and framework and design.
Alright, so in the world of Python, there are many packages out there, and researchers usually pick either one or two, a bunch of them to write their models and evaluate based on what the packages has. So mainly, we're going to discuss 3 most frequently used packages in Python. Namely, there are Natural Language Toolkit, Scikit, and PyEnchant. So the first one, Natural Language Toolkit, is really a powerful NLP package out there. It supports multiple semantic parsing and tagging of the natural languages. It's really powerful, but in the sense that for our problem definition, it's too general, in the sense that it almost suits for any NLP problems. The second one is the scikit-learn, which is also really powerful. Packages includes all the machine learning models and how to evaluate, how to do matrix decompositions, etc. But in terms of NLP problems like text, it does not support many in those models, so it has some deficiencies out there. And the third one we're going to talk about is PyEnchant, and it's a spell checker tools for software engineering. Mostly software engineers, they use it somewhere in their code to provide like these functionalities. But a problem with that is really it comes with really predefined models that are highly rigid and cannot be easily customized, which leads to our main idea. So we know there are this many packages out there, but really a framework like genetic framework that support like training, testing, and evaluating of models for the text corrections problems is missing. So that's the part where we want to dive into and spend more time on. Now we're going to talk about the design of how we're going to how we design our framework and how it fits into the problems. The framework we propose including the major following components, namely there are models, dataset, evaluation, and the matrices. Models are pretty self-explanatory. They include all the models in the related field for usage, and so user can directly invoke them for like as a black box. Dataset components is just include all the approaches to input and format the dataset, and for the training purpose or for evaluation purpose. The evaluation component is basically responsible for evaluating the models you have, and based on different approaches, different evaluation methods. And matrices are just including all the major matrices for text corrections. Then we're gonna dive a little bit more into each of the components we have here. So for datasets and evaluations, we provide convenient interfaces to import datasets from either text files or any other major like sources, and perform evaluations for evaluation components. So mainly we support multiple n-gram language models that you can directly import them from the text files and import them as a dataset. And also the evaluation method for text corrections are basically we think the following three are related, namely expected precisions, expected recall, and expected F1. The definition of those can be found within the reference paper. And then it comes to the models and the metrics we have in the framework. In addition to the dataset and evaluations, models are metrics includes generalized hidden Markov models, and for matrices we have edit distance and noise channeling, and etc. Notice like since we're really proposing a framework, like it has to be generic enough, so all the 4 components that I have mentioned before are all flexible. Namely, we define some base classes that are some base interfaces that can be used across the whole framework. So the picture we have on here is a base class for models. So whenever user want to define their own models, all he has to do just go ahead, implement based on this scheme, and the framework will take care of the rest, like evaluations or datasets. Then I'm going to talk about what we have so far and what things should be we plan to do before the next week. So implementation is still an ongoing process. So things we have done so far is basically architecture and designs. How do we really mimic the process of evaluating, proposing models, and etc. And we also loaded a bunch of predefined datasets and how to really parse input from the based on user-defined functions. Those predefined datasets include like n-gram datasets and major like really large dictionaries or whatever. And also we implement a bunch of matrices for evaluation purpose, namely edit distance and noise channeling. And the things anticipated that we want to finish before the report is due is basically we want to have more models into our the models in components, including the general hidden Markov model, which is discussed in the reference paper, and more if we have time. And also some evaluation scheme that we discussed earlier. This is also thing that we're gonna incorporate into the framework. And now we're gonna show a brief demo of what we have so far.
I will show the demo for our framework. So right now, I will just open my terminal, and using Python shell to do that, I will just import my package. So for the demo purpose, we're just using a relatively small data set, and first we will call our parser in the framework to parse the data and train the language model and error model on that part. And then the framework will save the result, and if we give it input like this, it will just give back the correct format of this word. And we can also try something like this. And I can also input a phrase. So the function will call the model in the framework, and using the data sets we calculate to find the maximum probable to find the optimal correction for the word and return the result. In the future, we will implement other models like Sri said, and we will also finish the evaluation part. So in the future, other than just give it a wrong word and return a correct format, we will also run our model on some evaluation data set and return the evaluation metrics for that model. So that's it for now, and thanks.